Hello, we come to the second part, Unit 2 of chapter number 3, Balancing Chemical Equations. Going to share this slide PowerPoint presentation with you. And so just give me a minute to find it. And here we go. Got it. Now, under Unit 2, we're going to study reactions and solutions. The objectives and student learning outcomes are as follows. Explain the difference between electrolytes and non-electrolytes and recognize examples of each. Predict the solubility of ionic compounds in water. Recognize what ions are formed when an ionic compound dissolves in water. Recognize exchange reactions in which there is an exchange of anion between the cations of reactants in solution. Predict the products of precipitation reactions and write net ionic reactions for reactions in aqueous solutions. So let's start with the first one. What is an electrolyte and what we consider as non-electrolytes? Electrolytes conduct electricity or current. They are strong electrolytes contain 100% ions. Weak electrolytes have more molecules than ions. Non-electrolytes does not conduct current. Water is a non-electrolyte. The concentration of the H ion and OH ion in water is too low to conduct. Therefore, we can say that water mostly consists of H2O molecules. Why are electrolytes important? Electrolytes play a very important part in balancing body fluids. The chem screen panel analysis for sodium ion, potassium ion, chloride ion, phosphate ion, and calcium ion. So whenever we want to study how much of these ions are there, we use a chemistry panel and find out. The conductivity. No ions present, then we call that as a non-electrolyte. Few ions present, we say weak electrolyte. Lots of ions means we say strong electrolytes. Conductivity properties. Solutions. Question to ask yourself. Molecular or ionic? Conducting? If so, strong, weak, or none at all? Best symbolic representation. Now, this is a conductivity demo experiment. You have a conductometer. You have the two electrodes connected to a bulb, and the electrodes are dipped in a conducting solution. And you can see if the solution conducts electricity, the bulb will glow. If it doesn't, it conducts weakly, then the bulb glows dimly. And if it does not conduct, it will not glow at all. And that's how you can find out whether a material is conductive or not. And you can do the same type of testing using dill pickle. Now, NaCl, this solution is a strong, weak, or non-electrolyte. Answer the question. And the solute is the solute molecular or ionic? Again, you can answer the question because you know that NaCl completely dissolves in water, so you can. What about sugar? Sugar is a molecular compound because you don't see any cation anion. It is a combination of carbon, hydrogen, oxygen. And therefore, what would you expect the conductance of this solution to be? Again, hydrogen chloride or HCl. If it is dissolved in water, then we can write it as H plus AQ plus Cl minus AQ. And under this form, you can find out, you can decide how the solution will behave. Same thing for NaOH. Now, again, another example, ammonia. Whether all the time follow the questions that is asked. Is it molecular? Is it ionic? Does it break up into cation and ion? And then you answer the once you get the answers, you can find out whether it's conducting or non-conducting, and therefore an electrolyte or non-electrolyte. This is a general chart for you to just have a glance at. Solute. When a solute is in an aqueous solution, ionic compounds, they dissolve completely to give strong electrolyte ions. Then non-molecular compounds, most of them are non-electrolytes. But however, some of them, like weak acids and weak bases, you can have, if they are strong acids, then of course they will dissolve to give a strong electrolytes. If they are weak acids and bases, then again they will not. They will be low or low conducting electrolyte. The conductivity properties, solids like metal spatula, wood spatula with a wooden handle, sodium chloride, then sugar, and liquid water. Now, reactions in aqueous solutions. Distinguish between ions and molecules. What predicts a reaction? When we say what predicts a reaction, basically we are asking what would be the result, or what is the driving force behind a reaction. And then generally we say that there are three categories: of formation of a precipitate, which is an insoluble solid, formation of a gas, or formation of a weak electrolyte. These are the driving forces for a reaction. In water, now, one of the things that's most important is you have to know the solubility rules. How do we know if a compound will be soluble in water or not? For molecular compounds, the molecule must be polar. Well, a very, very brief introduction to polarity over here. We'll do that in greater depth in chapter 8. Polar means it must have a neutral molecule has a positive charge and a negative charge on itself, so that the net charge of the molecule is zero, but still, because of the existence of charges, it can dissolve in water. For ionic compound, the solubility is governed by a set of solubility rules. And here, learn the exceptions, because it is really hard to remember all the rules. And it is a good idea to do that, because in many cases in multiple choice questions, these exceptions play a very important role, so you can quickly identify whether a product will be water insoluble or not. Now, chemical reactions in water are considered as exchange reactions. The anions exchange between the cations, and when a precipitate forms, one of the products is insoluble. Based on the solubility chart, try to go back and look at the solubility chart and predict whether the compounds are water soluble or water insoluble, and which ones are water soluble, which ones are water insoluble. And that will sort of give a trend to you to form an informed judgment and learn the rules. Precipitation reaction, the driving force is the formation of an insoluble solid called as a precipitate. For example, lead nitrate, when reacted with potassium iodide, gives potassium nitrate and lead iodide. Barium chloride, when reacted with sodium sulfate, gives you barium sulfate and sodium chloride. And you can see the reaction of how the precipitate forms. And these are different types of reactions with different precipitates. And you can see this is one of the aspects of chemistry that's really beautiful to watch. When you perform the experiments, you get so excited because of the formation of different colors that are there as a result of the precipitation reaction. Here are some definitions that students must know. Complete molecular equation, an equation in which all substances are written as if they were molecular substances, even though some may actually exist as ions in solution. Ionic equation, an equation for a reaction involving ions in solution in which soluble substances are represented by the formula of the predominant species found in the solution. Spectator ions are ions in an ionic equation that do not take part in a reaction. And the net ionic reaction equation is an ionic equation from which the spectator ions have been removed. And this is very, very important when dealing with precipitation reactions. And here are another set of the guiding rules for solubility and the precipitate of various compounds that are formed in combination with the same cation and sometimes with different cations. And you can see the color forming. The copper nitrate plus 2 sodium hydroxide will give you copper hydroxide plus 2 NaNO3. One of the first things is all sodium salts are water soluble. So now the question you have to see is whether copper hydroxide is soluble or insoluble. This type of reaction is called as metathesis reaction, double displacement reaction, or exchange or swinger reactions. The predominant species are copper hydroxide, sodium ion, and nitrate ion. And there is another one where the same reaction is shown in the form of a net ionic reaction. When we remove the spectator ions, the net product is what you see, and that is a solid. And here are some examples for practice. Again, answer, you check out everything. Now, in this case, HClO4 is an acid, KOH is a base. And when an acid and base react together, water is formed. And so the answer is designated as B. What happens when you combine nickel nitrate and ammonium sulfide? Look at the solubility chart. This is an exchange reaction. Again, all ammonium salts are water soluble. So look at the nature of nickel sulfide and then decide what kind of product would you get. And after this, you get self-study questions that are there. Solve them so that you understand the various concepts. And with that, I'm going to stop the share. And so shortly we will start unit number 3, acids and bases.